ít nhất là phải xong cái phần tính thép hoàn toàn, thấy không? Và như vậy nói luôn là qua Tết, cái ngày đầu tiên chúng ta đi học lại cái môn này là deadline cho việc nộp cái phần vẽ móng băng. Tất cả nghe rõ không nè? Đó. Cái ngày đầu tiên sau khi đi học lại qua Tết thì là deadline của việc nộp cái phần vẽ móng băng. Đó. Deadline có nghĩa là những em nào mà đã vẽ xong cái phần móng băng rồi thì có thể là nhanh chóng nộp để thầy duyệt bài, duyệt cái phần vẽ móng băng. Rồi, đấy, các em lưu ý đó. Rồi, tiếp tục chương trình thì tiếp theo các nhóm 3, 4 và 5 sẽ tiếp tục trình bày các cái topic như thầy đã giao. Nhóm 3 đâu rồi? Rồi, bắt đầu được rồi ha.
Hello everyone. Today Rotary is gonna talk about nodular pies. Rotary includes two members, me, Phan Võ Kim Thư, and Trần Ngọc Hương Uyên. And let's start. The contents is, includes 4 parts. The first one is description in details, composition of pies. And the next is scope of application, and the third one is production process, and the last nodular pies installation. Yeah. Yeah. I'm gonna talk about the composition of pie. nodular piles is a retention concrete pile. So what is retention sponge concrete piles? Um, the re- retention sponge concrete pile is a restrained concrete piles and are manufactured on a high-tech line, manufactured by high-speed centrifuge, reheating high compressive strength and are capable of bearing compression and as well as waterproofing. And the technology used in mainly redressed concrete. There are three types of retention sponge concrete piles. The first one is retention sponge concrete pile, uh, or BC, retention sponge high strength piles, BHC, and retention sponge high strength nodular, MBH, according to DCVN. So today we're gonna talk about nodular piles. So nodular piles is or retention sponge high strength nodular is redressed centrifugal um, concrete pile with a new design, a rib shape on the concrete pile to improve the friction and loading capacity of concrete piles. Um, the and MBH piles have not on the pile body and cross section area is enlarged at the knot and the basic dimensions are shown in figure. The outer diameter or pile length and uh, the outer diameter of of the pile or uh, nodular diameter is um 40 450 millimeter or less, and the nodular diameter should not exceed plus 150 meter compared to the outside diameter of the pile body. For pile with an outside diameter greater than or equal to 500 millimeter and the knot diameter should not exceed 200 millimeter compared to the outside diameter of the pile body. And next slide. Yeah. As you can see, the distance between two knots is always 1 meter. And in this picture, that the cross section of the file G800 and 600. There are two types of nodular pile. The first one is D600 of 450, and the second one is the 800 and 600. Yeah. Uh, yeah. And the concrete and reference file. The concrete about the concrete, nodular piles have the compressive strength of concrete with cylindrical test piece of 150 plus times 300 millimeter and not less than 80 megapascal. And the cement for the production of piles used for corrosion environment is sulfate resistant Portland cement in accordance with TCVN 6067-2004 sulfate-resistant mixed Portland cement or PCB HSR in accordance with TCVN 7711-2030. It is also possible to use other type of Portland cement in combination with active additives to meet the requirement for resistance to corrosion. And the rebar the reinforcement used for manufacture of pipe conform to the respective standard, with rest still conforming to TCV, and as you can see, there are many types of rebars can be used in this pile. we go into the next part, the scope of application. As one of the remedies of style in subsoil, the retention spun concrete piles are applied widely in many fields, such as building engineering, traffic engineering, port engineering, and hydraulic engineering. However, there are many limitations in technology, such as its lower resistance to bending and shearing, and poor linking manner, and du- durability of connection between pile sections. A new style retention when concrete nodular pipe can address this problem. The main construction technology, mechanical bonding manner, and bearing character are improved, aiming on the shortcoming of the traditional retention bond concrete pile. So, through the comprehensive and intensive static loading test, the bearing capacity of new style retention spring concrete nodular pipe is much higher than that of the ordinary one by at least uh, 26%, especially its ultimate uplift resistance and can be increased enormously, which the engineer is quite concerned about. Finally, the bearing mechanism and how the new nodular pipe improve the skin region are developed. So the new style retentions when concrete nodular pipes have many more compared to the traditional one, which is helpful to its spread and application in subsoil. But there's one question that uh, why nodular pipes are not popular in Vietnam, although it's cheaper construction fee and better quality than ordinary pipes. The answer is the cost to invest in a pipe stretch machine is quite high, um, and because the pipe is long, it will be difficult to transport. And the most important thing is the popularity in the province is not much, so we have many difficulty finding and learning about it. Uh, yeah, the next part is upstream. Um, Next part, I will introduce to you the production process of nobular pile. Um, there are overall 12 steps to produce a nobular pile, and first of all, we need to check the materials inspections before we go into the production process. Um, the second step is in the factory will make the steel rebar cage um, by machine, and the number three step is setting the piles placing in the head of the cage. The fourth step is setting steel cage into a mold. Step number five is concrete mixing. Um, in this step, the concrete will be mixed by a big machines, and this machine will control all the process of mixing concrete in very exactly ingredient.
such as how much water, how much cement, and how much rock and sand into the concrete. Um, the sixth the sixth step is pouring this concrete into the mud, and after pour after pouring concrete into the mud, put the we put that mud into a machine to centrifugal casting, and then after the seventh step, we need to in a steam current it in a temperature of about 100 Celsius degrees Celsius to dedicate to remove the mud early. Hot stream will accelerate by hydration of concrete in a high temperature, and normally steaming by about 8 hours, depending on the technology or its manufacturing plant of this factory. Um, and then we will, after steaming 8 hours, we will remove the mud. Then we check again the products in inspection. Then we will mark the number of the day of production in the products, and lastly we will let the noble apply nature nature to natural curing. And as Thuc said, why the noble pie is not popular in Vietnam, so I want to compare again between advantage and disadvantage of noble pie. First of all, we talk about the advantage. Um, Firstly, each noble pie is cheaper than the other pie because one centrifugal concrete pie with one ordinary concrete, the cost of centrifugal pie is cheaper because it can economize or decrease the amount of concrete used to production. And secondly, pie available it's very quickly to order, and the length can be up to 13 meters for each pile. And the disadvantage is to produce this pile, we need very advanced much manufacturing system, and then it make a high investment in pie press machine. And secondly, it's because it's very long, and dense transportation is very difficult. And lastly, the popularity level in the province or locally is not very popular, then so you can have difficulty in researching and apply it in a local area. The fourth part, we move to the how install the noble pie in foundation. Step one, that we need to locating the pie positions and excavation with a diameter up to 700 millimeter hole drill, and use the diameter 600 hip. Then a pie lowering is used of a machine to drill into soil and rocks in order to create a hole larger than the diameter of the pile body, and the length throughout the length of the pile body are shorter or longer depending on the geological conditions. Step 2 is mixing and pumping sharp cement milk. Um, this this step will be mixed in a machine, just like in the production process, but it's made in on site of the construction. Um, After we need to pump and push the cement mortar in the borehole from the bottom up. The ground volume is calculated to be enough to fill the void space between the concrete pile and the borehole. And step 3 is pumping paste cement into hole. We need to pump from the bottom of the borehole according to the corresponding ratio. And before pumping, it's necessary to make the bottom of the hole. And step 4 is inserting and setting pile into the hole. Print and lower the pile into the borehole according to the design depth to ensure that the pile must be vertical. In case the pile is not deep enough according to the design, the pile can be welded. It's the step 5. We need to welding numerals of pile together to get the design depth. And the last step is in the process of dropping, we need to pressing the knob of the pile, and then we take a test of PDA after 7 to 10 days. About the test of PDA, the group 7 will introduce to us, so I don't mention it in my presentations. And after I illustrate to you the process of production and installation, the novel pie in, and then I will show you some videos to make it clearly. And that is the end of our presentations. Thank you for listening. Um, do you have any questions for us? Dạ thầy ơi.
Okay. Next is question and answer section. And the first question for Vũ Hùng. Where are you, Vũ Hùng?
Yeah, yes, I'm here.
So tell me, what is the nodular pile?
The nodular pile is um is a pre-stretched centrifugal concrete pile with a new design. Uh, the aim is to improve the friction and the loading capacity of the concrete pile.
So your definition is not clearly.
Um, to add more, the it have a knot. It have knots on the pile body, and the cross sectional area is enlarged at the burning position. And basic dimension, it's just like a tube with some uh, it's like a bamboo.
So what
uh,
is the function of the nose inside the pie body?
is to increase the to increase the friction, into the friction, link the pile to the ground, to be more stable.
And how do you decide the diameter of such nodes in pie body?
It I think it's I heard from the presentation is just usually bigger 150 millimeters compared to the diameter of the pile.
Okay, you can stop here. And second question for the authors of this presentation. So how do you check the rebars of nodular pile?
Um, um, uh, we need some minute to find the answer. Can we take some minutes, please?
2 minutes.
Yes, thank you, sir.
Teacher, we have the answer. Um, According to the design, we have the section of reverse design in nodular partner. So, and then we gonna take some tests, and if it meets the spec of standard, so the reverse infile will be satisfied. And this is the end of the answer.
No, I don't think so. It's just a field test. And how do you know whether or not your rebars is sufficient to support the applied load from the upper structures?
We have the table to yeah, this maximum breaking moment and effective stress and shearing strength that one pi can assure. Yeah. So if the moment or the stress is um bigger than that, so it will not be satisfy the standard.
Okay, last question for you. How do you design the cement mill surrounding a nodular pile?
So this pie is very new in Vietnam, and we have uh, very little information about this concrete and the rebar. So we just know the factory that can produce this, but we don't know anything about this.
So
So
you two should study further information about the cement mill surrounding a nodular pile, and I want to have a correct answer for this problem by the end of tomorrow morning. Okay,
uh, mail or we send you the answer
email by
email.
email
Yeah,
by
yeah,
the end
please.
of tomorrow morning. I want to get by
Yes.
email correct answer for this question. Okay.
Yeah. Yes. Yes.
Okay, so you can stop here.
Thank you.
Thank you,
Let's have
teacher.
let's have the next presentation by group 4, Vũ Hùng and Xuân Trường. Are you
Okay,
ready?
teacher. Yeah, yes. Okay, so hello teacher and everyone. Today I will present, me and Sun Trường will present to you about the pile rough foundation. Okay, so first we have to know what is pile rough foundation is, and the definition of it is uh, a raft foundation. A, a pile raft foundation is a raft foundation has pile to reduce the amount of settlement. The raft foundation and the pile would be designed to act together to ensure the required settlement uh, is not exceeded. The pile raft uh, is a foundation constructed by combining both the pile and the raft foundation. Firstly, the piles are constructed, and then the raft is like combining all the piles. It's like the picture. Uh, this is the section drawing. The picture on the left is the section drawing of the pile raft foundation. Uh, the pile raft consists of two parts: the raft and the pile. The raft or the pile cap is responsible for connecting and distributing the load from the foot of the structure to the piles, and at the same time transferring a part of the load to the ground at the contact point between the bottom of the raft and the ground. The raft can be made of flat slab or beam to increase the stiffness against bending. The pile are responsible for transmitting the load to the ground under the pile foot through the nose resistance and into the ground around the pile through the lateral resistance. Pile can be arranged in group or separately, arranged along the line or arranged in any position depending on the purpose of the designer in order to correct uneven settlement, reduce pressure on foundation and at the bottom of the raft, or reduce internal force in the raft. So why people using this pile raft foundation? So it have uh, s- uh, some advantage compared to the other foundation. First, the additional piles reduce the settlement and differentials, uh, reduce the settlement and differential settlement. Mostly the pile provide its full capacity, and the balance is provided by the raft. And thirdly is improve the lateral force resisting capacity. And next, typical pile raft can be observed in the high-rise building where very high axial load are applied. And in the other way, when the pile cannot be socket in the rock due to the absence of the fresh rock, the pile raft are considered to resist the load. As a picture, there's a three kind of foundation that usually used as a raft foundation, a pile foundation, and a pile raft foundation. Compared to the full pile solution, the pile assisted raft has a major advantage of substantial reduction in number of piles, which is turn result in saving cost and time. Placing of piles in systematic manners under the raft reduce such settlement to acceptable values. In addition to the settlement, the bearing capacity of the whole system of the foundation also improve. And uh, we have to know there is how many type of pile raft, so we need to classify. Pile can be used prefabricated piles or board piles. Prefabricated pile usually include two types: precast reinforced concrete piles with or without the pre-stretching. And the steel pipe, the second is the steel pipe. It have a H-shaped steel or an tube shaped steel. And um, about the raft, there's two uh, a small pile or raft, which is the wire is smaller than the length. It have insufficient bearing capacity of the raft, and the pile is added to increase the factor of the safety. And the second one is a large pile raft, which have the wire is larger than the length, and is sufficient of bearing capacity of the grass, and it have a pile as to decrease the sediment. It's the difference between the two kind of pile raft. And in Vietnam, we usually use lower the prefabricated pile by the one of three methods: using the hammer to drive the piles, or peeling by hydraulic jack and counterweight system. And third way is a vibrate. It's yes, it's vibrate the pile to uh, put it into the ground. About a pour pile, a pour pile is a type of concrete pile constructed by pouring fresh concrete into the pre-drill hole. Like they just like a picture, the second picture, the under picture, they drill a hole in the soil already, and they put a tube on there. Then they pour the concrete into that tube, and they remove the tube out, and that's how you have the pour pile. Keep going. We will talking about the working mechanism of the pile raft foundation. Uh, the out um, the the outstanding feature of the raft pile foundation is the mutual influence between the soil and the foundation structure during the loading process, according to the following four influence. First one is pile soil interaction. Second one is pile pile interaction. Third one is raft soil interaction. Four is pile raft interaction. And the study of the reciprocal effect when it's come to the influence of the pile cap, the ground under the base, and the pile show that the load transmission structure is as follow. First one is working of a pile cap. Pile cap. The second one is the influence of the ground on the bottom of the tower. Next to that is the impact of the pile, and the last one is the working of the pile group. Uh, next one, next one, please. Yes. Uh, we have to talk more detail about the working of the last one, working of the pile group, because we have some more information in there. The load capacity of the pile group is also smaller than that of more than that of a single pile. Like here we have to demonstrate to you, uh, and like in the figures is the slash contour of the single pile and the group of pile. When driving or pressing piles into the coarse grain soil in loose or medium compact state, the soil will be compacted, thereby improving the bearing capacity of each pile nearly to one. When driving or pressing the pile into a cohesive soil, the soil structure is damaged, disturbed. The load capacity is greatly reduced. After the period of the rest, the shear resistance will gradually recover, but rarely recover to 100%. So that number is closely to 0.8 or 0.9. and and the and the working of the pile soil system is the unified system that work together and interact with each other in very complex way. That interaction depends on the flexural and stiffness of the pile cap and the stiffness of the ground, the base of the cavern, and the stiffness of the pile. Thanks to that interaction, the load is distributed to the ground, causing displacement of the foundation, which redistribute the load to the structure above, and thereby adjusting the settlement difference and maintaining stability and nail the space. However, there are not always enough type of interaction between the soil and the foundation structure. So, depending on the actual data of the foundation and the soil, we can assume to remove a certain type of interaction to a simple calculation. Next one, we moving to those factors that affecting behaviors. These following factors are known as important to consider when designing of the pile raft foundation. First one is number of pile increase. Uh, Number of piles when the number of piles increase, it will maximum the settlement. The maximum settlement will decrease and the load carrier increase. The second factor is the diameter or length ratio of the pile. In when it increase, the differential settlement will decrease and the maximum moment decrease. So it's best to increase the length of the pile than increasing the number of the pile. Uh, there are some more factors like pile spacing ratio, location of the pile, the stiffness of the piles and the raft, and the raft dimension, and the soil type and the stiffness of the soil, and the load distribution over the pile raft. Moving to the next one, this is the effect of the ground condition on the pile raft behavior. As discussed at the beginning, different interaction of the pile, soil, and the raft are the key factors that cover the behavior of the pile raft. Therefore, the condition of the ground is significant effect on the load carrying capacity of the raft. Therefore, soil profile containing stiff clay or dense sands is favorable condition for the pile raft. However, if the soil profile is subjected to following formation, it could lead to reducing the load carrying capacity while increasing the settlement. Having the soft clay near the surface, or having loose sands near the surface, or having the soft compressible layer at the shallow depth, and having the soil profile likely to undergo the consolidation settlement. And the last one is having the soil profile undergo the swelling movement due to external causes. So how we will apply the pile rough foundation? The pile rough foundation is often used relatively much in construction work. The reason for making a pile rough foundation is because in the case of very thick soft soil, it is not enough to arrange the pile according to the single station or taps on piles. It is necessary to arrange piles on the entire construction area to carry the full load of the work. And in addition, rafter will increase the overall stiffness of the foundation to compensate for the weakness of the ground. Like for when applied for rational house, the mainly raft foundation on stuff pile or barrettes, while a pile raft foundation is suitable for pile structure, the wall frame structure. In industrial buildings, mainly raft foundation on piles driven or pressed. The industrial buildings are characterized by large ground area, often unstable geological. structure, and the pile used in this work often have the effect of reinforcing the foundation, reducing the deflection of and the absolute settlement. In in When building a port or and water works, the mainly rough foundation on driven or pressed piles. The characteristic of these work are heavy load bearing, strict regulation on absolute settlement and deflection settlement. Example of the structure of these types are ship locks. We taking example here is the building 97 in Láng Hạ Street, district Đống Đa, Hà Nội. The floor plan is 43.6 and 34.5 meters. Frame wall structure using board pile with diameter 1,200 and calculated load capacity of single piles is 650 tons. The foundation consists of 65 piles arranged throughout the house, and the foundation raft is 2 meters thick. Um, uh, this Currently, the design when designing a pile foundation type, pile raft foundation type, pile rafter often have some calculation point as follow. First one is the pile bearing full load. In this view, the piles are designed as a group of piles to fully accept the load of the building without regard to the load bearing participation of the ground under the pile cap. In the calculation, the founder system is also calculated as low pile foundation with many approximate assumptions such as horizontal load received by the ground above the base level of the platform. The foundation is absolutely rigid. The rigidly attached to the pile transmits only the vertical load on the pile, so the pile is only subjected to the tension or the compression. Or the piles in the pile group work as a single pile, and the piles bear the entire load from the foundation girder. When calculating the overall pile foundation, consider the foundation system as the conventional foundation block. Calculating in this way has the advantage of being simple, safe, and detailed in current foundation textbook. The test settlement of the foundation calculated by this method is small, using many piles and often more safety factor and the safety factor is higher, not fully promoting the load-bearing capacity of the pile. Thus, we see that it has the disadvantage of being too safe or uneconomical. So this is a wasteful option. Second one is simple. Is from raft bearing the full load. From this point of view, the rafters are designed to bear the most of the load on the foundation, and the pile receive only a small portion of the load, and are arranged and they are arranged to limit both the amount of load carrying capacity with the main purpose of reinforcing the foundation, reducing means and offset. The settlement of the foundation in this field is often large, exceeding the allowable settlement. In addition, which large construction loads calculated from this point of view often do not guarantee the load-bearing capacity of the ground under the foundation. Um, and the last one is the pile raft bearing the load at the same time. According to this point of view, the foundation structure system, the pile at the same time work with the ground in a unified way, taking full account of the interaction between the soil raft piles elements. In this way, the pile, in addition to reducing the settlement of the building, also promote the full load capacity, so fewer piles are needed, and the length of the piles is smaller. When the pile has fully developed its load carrying capacity, a part of the remaining load will be carried by the raft and work like a raft foundation on the natural foundation. In this field, the sediment of the building is usually larger than that of the fully loaded pile, but overall it is still within the regulation with reasonable factor of the safety. So the calculation of this give better economic efficiency than the first one. However, the calculation process require the use more complex model, so this field is not widely available at the present. Like the figure 10, the low settlement relationship. The settlement relationship according to the design point of view. Okay. And the next part is by June.
Okay, next is question and answer session. And the first question for Anh Hoàng. Are you ready?
Yes, teacher.
So tell me, what is the Pirate Foundation?
The uh, the Pirate Foundation the is interaction of the pie, soy, and crab.
What
It,
is the Pirate Foundation?
Pirate Foundation is a pie. Is a crab foundation has a pie to reduce the amount of settlement, and the pirate the rap foundation and the pie would be designed to act together to ensure the required settlement is not exceeded. The paragraph is a foundation constructed by combining both the pie and the crab foundation. Uh, and the
So
pie, yes.
are there any differences between a Pirate Foundation and a conventional Pi Foundation?
Different between I uh, it have the rap foundation it have the it's above the pie. Uh, uh,
Okay, you can stop here. And next question for the authors of this presentation. So show us the slide number 16. Okay. So in that slide, you said that calculation method is look like Pi Foundation calculation method. Really? You show us a formula to determine the reaction on the top of the pi pi. So in that formula, what is n? What is n in that formula? Uppercase. So according to that formula, 100% of the vertical load from the upper structure is supported by the pi group, right? 100% of the vertical load from the upper structure is shared by the pi group according to that formula, right? But in that formula, you didn't take into account the pi cup, only the pi group. So can you apply that formula for the pi group foundation? No, it's wrong, totally wrong. So do you know why? Because if you apply such formula, so what is the loss share by the RAF? What is the percentage of loss share by the RAF? No, wrong, totally wrong. 100% of the vertical loss is supported by the pi group. Therefore, the percentage of loss share by the RAF is 0. So you cannot apply that formula for the pi RAF foundation. Okay. And next question, how do you determine the settlement of a pi RAF foundation? So what are the computer software can be applied to find out the settlement of a pi RAF foundation? No, it's just a structural software, not geotechnical software. So you cannot use SAP software for a geotechnical problem like a pi RAF foundation. That's right. However, it's a commercial software, so if you want to use that software, you have to pay a lot of money to get the license. Okay, it's not a free software, so you have to pay a lot of money if you want to use it. And that is the numerical method. And I want to know the analytical methods. Is there any analytical methods or something like that to determine the settlement of a pi RAF foundation?
You mean like the more saving methods, the more economical?
No, no. the analytical method to determine the settlement of papyrus foundation if you don't use the computer software. No, you cannot apply a calculation method for pi foundation.
Uh, I think it's using the soil data from
No,
researching.
no, no. Oh, okay. I want to have a correct answer by the end of tomorrow morning. Okay. For this question, I want to have a correct answer from you by the end of tomorrow morning. So you can stop here.
Thank you, teacher.
Let's have a break about 20 minutes. Okay. Okay, let's continue to have a presentation by the group number 5.
Hello, teacher. Today I'm gonna present the topic static load test for the load bearing capacity of a single pi. And first of all, we will move to the definition of the static load test. Uh, Static load testing applied the load incrementally to a deep foundation element while measuring the foundation movement and the type of static load test include uh, the 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 axial compression and axial tension and lateral all based on the ISTM standard. And the static tests are typically performed to a maximum applied load equal to uh, mul- multiple multiple of foundation design load or to geotechnical failure. Compression tests utilize an overhead reaction beam and frame with resistance to apply load and provide by reaction pi or dead weight. And tension tests also utilize an overhead reaction beam and frame uh, or use the only reaction beam support the mat. And we will find the purpose of this uh, experiment. So the pi testing by axial static load method uh, can be carried out at stage design, exploration, and construction quality check. And static load test of pi at the design exploration stage conducted before mass construction of pi to determine the required design data on strain deformation and load displacement relationship of pi basis for designing or adjusting the design scheme, choosing the suitable equipment and technology for construction. And the last is static load test of pi at the construction quality control stage conducted during the construction period or after the pi construction is completed in order to check the bearing capacity of the pi according to the design and construction quality of the pi. Now we will find the uh, the equipment in this experiment. And this uh, this overall picture of this thi- this static load test. Now the first thing need is the castaway uh, uses used in the static compression test of pi at the construction site or precast concrete castaway arranged in block on a steel supporting beam system, and the maximum loss is higher or equal 120% of maximum test load. Then is support beam or reaction beam is a reinforced steel frame system calculated and manufactured enough to withstand the maximum test load uh, about 300 tons. The main bearing grid is one box with made of 1,400 millimeter high steel reinforced with the box, and the auxiliary beam system is a system of the high steel beam about 1,500 millimeter places on the support beam on the support system, and this beam system is reinforced and does not deform under load as well as during the test. Next is the beam bearing. This system consisting of many prefabricated reinforced concrete lot of different size and lot enough to support the experimental counterweight system placed on the ground to support the lattice beam system. The bearing system is calculated with enough cross section to ensure that it's not cause settlement when the lot is applied to for the test, and does not affect the working of the pie as well as other equipment during the test. Now, this loading system, the the experimental load system in the project is using the hydraulic jack with a lifting capacity greater than 150% of the maximum test load. Hydraulic jack are tested and certified by a function unit and receive the inspection. And this checking system is placed on the top of the test pie. The axis of the hydraulic jack uh, considered considers with the axis of the pie, and the checking system uh, the checking system and the transmission beam ensure the transmission of the load at the center of the test pie. And now this is the displacement measure system using in this experiment is the dial gauge, uh, including including for settlement gauge with the largest measuring range of uh, 50 millimeter with an accuracy of 0.01 millimeter, which are fastened to the test pie body through a magnetic support system and steel cuff, which are equipped with function unit, inspection and certification of inspection, and the hydraulic pump system. The hydraulic pump system is attached to the hydraulic jack by a pipe supplying oil to the jack to adjust the jack lifting capacity according to the design pump uh, lower according to the design pump flow 3 liter per minute, and maximum pressure is 600 kilogram per centimeter square. And this is a standard beam system. The standard beam system, also known as the meter bridge, has sufficient rigidity and is not affected by the winter shock. Distance from the foot of the bridge support, the clock, then the friction point to the center of the pie is not less than 3 diameter of the pie, 3 times diameter of the pie. And this is the force measuring system. Uh, the force measuring system is system use a hydraulic meter with a measuring rod of 0 to 600 kilogram per centimeter square, and the compressive force acting on the test by heart is calculated through the reading of the pressure gauge and the lifting capacity of the hydraulic jack, which is tested and certified by function unit. And now we will move to the experimental produce. And first we go to the preparation before we start the test. So the pie that are tested should be checked for quality according to current standard for construction and assessment of pie. And the static class is carried out for pie that have enough time to recover the structure of the soil damage during the construction or concrete reaches strain. And for the ball pie, the test the rest time for the completion of construction to testing is minimum 21 days. And for other pies, the rest time for the end of the concrete pie pressing until the testing is minimum 7 days. Uh, the test pie and now the jack must be placed directly on the pie head pad and center relative to the center of the pie. And when using the multi project, the jack must be arranged so that the load is transmitted actually and centered on the pie head. And the pie head clamp is fastened to pie body uh, approximately 0.5 diameter or wide from the pie head. And the standard beam are places parallel parallel to the both sides of the test pie. The beam support are buried firmly in the ground, and the displacement meter is mounted symmetrically on the either side of the pie head, and is mounted stably on the reference beams. The displacement of the displacement meter is supported on the pie head clamp or the pie head pad. Uh, the installation resistance for of the equipment specific uh, as follow here. From the center of the test pie to the center of the anchor pie or the ground anchor wing is larger than three times of the pie diameter, but in our case it's not less than 2 meter. And from the test pie uh, to the nearest point of the support is greater than 3 times of pie diameter, but in no scale less than 1.5 meter. And from the test pie to the standard beam support is not less than 1.5 meter. And the last and the last is from the reference point to the test pie, the anchor and the bearing are loaded with the load is larger than 5 times of pi diameter, but in those case is not less than 2.5 meter. And now we will go to the experimental procedure. And so before the conducting test, the experimental preload to check the operation of the equipment and create the contact between the test pie and the test device. Preload is equal to 5% of design load and keeping the load for 10 minutes. Then then reduce the lot to 0% level and readjust the displacement gauge to 0% lot level. So here it is hold, increase a lot to 5% is to eliminate the deformation caused by loading, and when we decrease to 0%, we must record the initial data. So, before we start with the first circle, we mentioned about the regulation of the increase and decrease the load. So the load each level, as you can see here, and the load to the maximum expected, the load of the 200% of design load, which each level of the load is equal to 25% of design load, and new load level is only increased when the settlement speed of the pi reaches the conventional stability. Uh, the convention stable settlement is not more than 0.25 millimeter, and keep it not more than and keep the load not more than 2 hours. Hold and after the end of the loading, if the pi is not damaged, reduce the load to 0 here. And each level of load reduction is equal to 2 times of the load level, and retention time of each level is 30 minutes. Except the load 0 might be longer. In here, at the load 25%, from 25 to 75% load. So we keep the lot minimum, each lot minimum 1 hour to reach the conventional stable settlement of 0.25 millimeter per hour, but not keep it more than 2 hours. And why on the test, why during the test, we must record the result at the time when we start, and after 10 minutes, 20 minutes, 30 minutes, 45 minutes, and 60 minutes. And when we increase the lot to 100%, we have to maintain the lot for 6 hours to it reach the conventional stable settlement, and record the result of these results when we start, and after 10 minutes, 20 minutes, 30 minutes, 45 minutes, 60 minutes, and 220 minutes. And we have to continue record the result once per 60 minutes until the allotted time. And this is the end of the first circle. Now, due to the regulation, we have to decrease the lot by 2 times. Is now is reduced to 50%, and keep it in 30 minutes, and record the result every 10 minutes after every 10 minutes. And the last is when the lot is when the lot at 0%, we keep in 60 minutes and record the time every 10 minutes to 30 minutes, and record the result at 45 and 60 minutes. And to the second circle, we repeat the test, the experiment, but in here at this circle, when from 20, from the lot 20 to 100, from the lot 20 to 100, we just keep the lot in 30 minutes and record the result uh, when we start and after every 10 minutes. And when the lot it reaches and the lot it reaches 125% and 150%, 175%, we have to maintain the lot minimum of 1 hour to reach the convention stable settlement, but not keep it, but also not keep it more than 2 hours, and record the result at when we start and at 10 minutes, 20 minutes, 30 minutes, 45 minutes, and 60 minutes. So when the lot it reaches, sorry, when the lot it reach the 200 percent, we have to keep the lot for 24 hours and to achieve the conventional stable settlement. And also we have to record the result at the time uh, zero when we start and 10 minutes, 20 minutes, 30 minutes, 45 minutes, 60 minutes, and 120 minutes, and continue record the result once per 60 minutes until the end of the of the allot time. And this is which the maximum lot of this test. So we will decrease the lot to 150, 50%. Keep this three time in 30 minutes, and also record when we start and after 10 minutes, and after each 10 minutes, and at 0%. So we have to keep the lot in 60 minutes and record the result at 10 minutes, 20 minutes, 30 minutes, 45 minutes, and 60 minutes. Now we go to know about the regulation of on destruction of the pie. We know this. We will show you when the pie is has have been destroyed, have been destroyed. So at the level lot smaller than the maximum test lot, the pie has settlement increase continuously without increasing the lot. The pie does not reach the conventional stable settlement after 1 day. Uh, holding the lot, uh, holding the lot at any lot, and at any lot, the total displacement exceeds 10% the pie size, or the damage. The pie is damaged. The pie material is damaged, and the last is the speed of the pie settlement at each lot is 5 times greater than the previous one. And this is the regulation on stopping the experiment. So the experiment must be stopped if the following phenomena are detected. First is benchmark or misplaced, unstable or damaged. Then is or the jack is does not work. The reaction system is not stable. The pie head is broken. The compression beam is tilted, and the crown is destroyed. But the test can be continued after the treatment remediation. And at the end of the experiment, so we achieve the goal of the experiment according to the outline, or the test pie is damaged. this is the video for the experimental procedure. And after doing the exam, the report result of we have the information, the number of the experiment, so we can summary the table of experimental result and the table of experimental data in the field. And from the result, we can draw the lot displacement relationship diagram like this. Is the relationship of load and displacement, or the time load time.
Hoàng ơi,
uh,
chưa xem màn hình.
Ủa, xe mà ta, sao bị gì ta? Oh, okay, I will repeat. uh, the After the experiment, we have the result. We have to summary the experimental result, and from the result we can draw the displacement ship, the last displacement relationship in diagram like this, or the time lot, uh, or the time lot and displacement relationship diagram. uh, and we move to the benefit of the static loss setting. uh, First is the static loss set. They provide information that can be used to for the deep foundation design confirmation and design refinement. And then the static lab test often allow a lower safety factor, or the higher resistance factor, to saving the construction time and money. And design can be optimized from the detail lot transfer information when the tests include the embedded strain gauge instrumentation.
Okay, you can stop here, and I want to ask you two questions regarding
Yes.
to this topic. And
Yes, teacher.
the first question, can we apply this static load test for the buried pile?
Uh, can you repeat the question, because I can hear clearly when at the end.
Can we apply this static load test for the buried pile
Baric pie. Uh,
or large bore pile?
I think is yes. We can apply this static lattice to the large pie.
Do you think so?
Yes. Yes, teacher. Is
Because for the buried pile or large bore pile, you have to use large counterweight.
yes.
And in that case, the counterweight must be heavy, so heavy.
Oh. Oh. So that's why we cannot use this test to the large pie or the buried pie. Oh.
Yeah.
Uh, okay, teacher. Yes,
And
teacher.
the second question, how do you determine the load bearing capacity of a pile from the static load test result?
So uh, there will be a machine like a static tester to give us give us the result in the diagram. And from the diagram, we will
No. Show what your previous slide says about the test result. Okay, that's slide.
yes,
Regarding to figure 4, how do you determine the load bearing capacity of a pipe from the figure 4?
figure 4. Uh, Wait. Uh, so there will be wait, sorry. Uh, from the picture board for in the maximum weight. This shows us the mass. You can repeat again the question, please. I forgot.
How do you determine the load bearing capacity of a pie from the figure 4? Okay, I want to get the correct answer for this question by the end of tomorrow morning. Okay?
Yes, teacher.
So you can stop here.
Yes. Thank you for listening. Okay. Để tắt. Rồi đã.
Rồi tiếp tục cái phần duyệt về các cái kết quả thiết kế tính toán móng băng á, thì có một số cái lưu ý như sau. Trước mắt là về cái nội dung tính luống cho móng băng đó, thì khá là nhiều em bị sai cơ bản, sai về cái phương pháp tính luống cho móng băng đó, mà lưu ý luống sai thì cái nội lực trong móng cũng sẽ là sai luôn đó, do đó mấy em là phải cẩn thận về vấn đề này. Lấy ví dụ một số cái sai phổ biến như đây là của Nguyễn Xuân Trường đây nè. Nguyễn Xuân Trường thấy không em? Đó, phải coi lại kỹ khi mà tính luống. Đó, cái áp lực gây luống ở trên này nó là 136,4 kN trên mét vuông, nhưng mà xuống tới cái bảng tính luống chia lớp phân tố, lớp thứ nhất thì sigma gây luống là chỉ có 92,4 kN trên mét vuông, thì như vậy nó không có khớp với ở trên. Đó, do đó là phải xem lại giá trị nào đúng. Đó, ở trên là 130 mấy đó, 136,4 là đúng hay là cái 92,4 này là đúng. Đó, một trong hai cái này là có vấn đề, là bị sai. Đó, nên mà nếu luống sai thì toàn bộ cái hệ số nền cũng như là nội lực trong móng là sai hết. Trường nghe rõ không? Rồi một bạn nữa cũng tương tự như vậy là Nguyễn Hữu Nguyên, có đây không nè?
Dạ có thầy ơi.
Nguyễn Hữu Nguyên, em chia lớp phân tố, lớp thứ nhất sigma bản thân là 49,96 và sigma ghi luống là 79,1, trong khi cái áp lực trung bình đáy móng là bao nhiêu? Áp lực trung bình đáy móng của em đây là 118,3. Thế thì lớp phân tố thứ nhất em tổng cái sigma bản thân với sigma ghi luống 49,96 cộng với 79,1 này, nó lại lớn hơn, nó lại là 128 gì đó, 129 gì đó, chứ không có phải là 118 như là cái giá trị ở trên. Đó, thì do đó một trong hai cái giá trị ở đây là bị sai. Độ lún ở đây là có khả năng là bị sai. Nguyên nghe rõ không?
Dạ vâng thầy, chờ em xíu em coi lại thử ạ.
Đó, coi lại cái đó. Thì đó là hai ví dụ tiêu biểu về việc sai khi mà tính lún. Đó, thì những em khác có khả năng là bị cái lỗi như thế này. Đó, phải kiểm tra kỹ lại trong cái phần tính lún này. Rồi tiếp theo là cái nội dung sau đó. Đó, từ cái việc tính lún cho đến tính thép cuối cùng. Đó, thì theo như kết quả nộp ngày hôm nay ở trên cái trang BK Learning, danh sách lớp là 15 bạn, nhưng mà trên BK Learning này mới có 14 bạn thôi. Đó, một bạn Trần Ngọc Hương Nguyên đã quá bài tập không có bài nộp. Đó, thì xem như đây là một cái ví dụ về không đảm bảo tiến độ. Đó là một trường hợp không đảm bảo tiến độ học tập. Trường hợp thứ nhì, một cái ví dụ thứ nhì ở đây là Cao Xuân Hùng. Cao Xuân Hùng có đây không?
Dạ có.
Cao Xuân Hùng mà cho tới bữa nay là không có thép gì hết, mới có tính lún thôi. Đó, trong khi lún đó là cái yêu cầu phải xong từ tuần trước, còn tuần này là đã phải xong hết cái thép. Em thì không có một cái chữ thép gì hết, thì coi như là không đảm bảo tiến độ. Xuân Hùng nghe rõ không?
Dạ thưa thầy, để em bổ sung sau rồi, tại vì em có nhiều cái bài, em xin lỗi.
Đấy, thì trước mắt em là coi như là không đảm bảo tiến độ. Đó, mà không đảm bảo tiến độ thì khả năng là sẽ cho thêm 1 năm nữa. Đó, để đủ thời gian để mà làm cho nó kỹ. Đó, thì thầy nói là đó là 2 trong số những trường hợp mà không đảm bảo tiến độ. Thì là các em không đảm bảo tiến độ là hết sức lưu ý. Nếu không là cần thì cho mấy em thêm 1 năm nữa. Đó, giờ này năm sau gặp lại. Đấy nha. Rồi, sau cái phần tính lún thì một số bạn là cũng có đảm bảo tiến độ, như chỗ Nguyễn Xuân Trường ở đây á, là có tính ra tới cái thép. Đó. Nhưng cũng có một số cái phần nội dung chưa có đúng hay còn thiếu. Đó. Thì những em khác theo dõi chú ý để mà bổ sung chỉnh sửa. Cái thứ nhất là nhắc lại là mấy em không chỉ kiểm độ lún tại tâm móng mà phải kiểm lún lệch giữa các chân cột. Đó. Như ở đây Nguyễn Xuân Trường đã có kiểm và nói rằng là độ lún lệch thỏa 2/1000. Đó. Nhưng mà cái này là chưa có thỏa. Trường biết sao tại sao chưa thỏa không nè? Em đang kiểm độ lún mà nói chính xác đây đó là độ lún đàn hồi, thì nó là 0,196, nhỏ hơn 0,2%. Thế còn nếu mà xét theo độ lún cố kết thì nó là như thế nào? Phải không? Để tính ra hệ số nền thì em dùng cái độ lún đàn hồi như thế nào? Em xác định như thế nào độ lún đàn hồi? Rồi, nhưng mà nhắc lại, từ cái hệ số nền em lấy độ lún đàn hồi là 0,5 độ lún cố kết, phải không nè? Đó, do đó là cái mà em ra cái BCDE ở đây đó là độ lún đàn hồi, mới có độ lún đàn hồi thôi. Còn nếu mà xét độ lún cố kết thì em phải là double lên. Như là khi em lấy hệ số nền chỉ có 0,5 độ lún cố kết. Đó, thì sau khi mà giải ra cái độ lún tại cột C ở đây á, là em phải nhân đôi lên thì mới ra được cái độ lún cố kết. Đó không? Đó, và khi nhân đôi lên thì như vậy là không có thỏa. Rồi, một cái nữa là em chưa có kiểm tra xuyên thủng cho móng băng. Phải không nè? Có kiểm tra chưa? Rồi, thế thì nếu mà kiểm tra thì kiểm tra như thế nào? Những em khác có em nào biết không?
Giờ kiểm tra cho 2 phần cánh móng không?
Đúng rồi, đó, kiểm tra cho 2 cái cánh móng đó. Và chi tiết cho 2 cánh thì kiểm tra như thế nào? Xuyên thủng từ sườn qua cánh. Đó, từ cái chỗ tiếp giáp giữa cánh với lại cái sườn móng. mặt phá hoại loe ra góc 45 độ. Đó. Có hai cái mặt sườn móng thì tương ứng sẽ có hai cái mặt phá hoại 45 độ. Yeah. Đó. Thì thiết kế đối xứng, do đó là chỉ cần kiểm tra cho một trong hai cái mặt phá hoại đó thôi. Và kiểm tra cũng như là tính cái thép cạnh ngắn đó, là mấy em không có tính hết cái chiều dài móng, mà kiểm tra xuyên thủng đại diện cho 1 mét dài của móng, cắt ra 1 mét và tính kiểm tra xuyên thủng đại diện. Đấy, thì đó là cái thiếu sót nữa. Rồi khi đi tính thép cho cạnh ngắn, dùng cái áp lực hay là cái phản lực nền tính toán, thì như trên màn hình đó, phản lực nền tính toán là không có kể vô cái gamma trung bình DF, mà chỉ tính tải ròng thôi. Đó, chỉ tính là tải cái chân cột thôi, lực chọc mô măng tải ngang thôi, không xét trọng lượng bản thân móng với đất ở trên móng vô. Rồi một cái nữa, tính cái CZ để mà nhập vô trong cái phần mềm giải nội lực. Thì như ở trường ở đây, CZ là P gây lún chia cho 0,5S, P gây lún là 150,85. Trong khi ở trên cái áp lực gây lún là bao nhiêu trường? Đó. Đó. Thì tại sao ở đâu ra cái con số 150 này? Là coi lại nha. Rồi, và một cái lưu ý nữa nhắc lại, khi mà mấy em bố trí cốt thép dọc ở tại nhịp hay là ở tại gối đó, thì cần bố trí thiết kế thép như thế nào để mà là có các cây góc thép ở góc là chạy suốt từ đầu này sang tới đầu kia của móng. Ví dụ như ở đây đó, là trong thiết kế của trường, trong dầm cho thép ở gối đó, thì phần lớn là thép phi 20, 3 cây hoặc là 2 cây. Nhưng mà có một cái gối ở đây nó là phi 18, thì như vậy là không có chạy suốt được rồi, mà nó là đứt đoạn đó. Như thế này là đang bị không có liên tục. Được chưa? Đó, thì đó là một số các cái lưu ý, những cái nội dung cần thiếu, còn thiếu cần bổ sung, cũng như là các cái nội dung chỉnh sửa. Rõ chưa? Các em nào có gì thắc mắc không liên quan đến cái phần tính toán tới bố trí thép này cho móng băng?
Dạ thầy ơi, cái phần mà mình tính xuyên thủng ở đây là mình chỉ lấy một cái một cái cột để mình tính, hay là mình tính lấy cả năm luôn?
Tính là chung là tính đại diện cho cả cái chiều dài móng luôn. Và ở đây không xét một cái cột nào đó, mà xét cho cả cái móng. Và xét cho cả cái móng, cụ thể khi tính xuyên thủng á, em sẽ so giữa P xuyên thủng với là P trúng xuyên. Thì P xuyên thủng em tính theo cái phản lực nền cho cả móng. Đó. Và thiên về an toàn thì em có thể lấy cái phản lực nền đó là P mắc tính toán. Đó. Thì khi tính cái P mắc tính toán đó thì em đã xét trong cái P mắc đó, phản lực nền đó, em xét tất cả các cái tải chân cột, gồm có tải đứng lẫn mô măng, gom vào trong đó. Thay vì em xét một cái cột nào đó thì em có thể là không có xét được ảnh hưởng của những cái cột lân cận. vào trong tính toán.
Dạ, cảm ơn thầy.
Rồi, có em nào còn thắc mắc gì nữa không? Nếu không có gì thắc mắc thì bữa nay chúng ta dừng ở đây. Đó, và với những em không đảm bảo tiến độ như là Xuân Hùng nè, rồi Hương Nguyên, đó là hai bạn tiêu biểu mà không đảm bảo tiến độ, thì một cái cơ hội cuối cho mấy em là chậm nhất giờ này tuần sau là phải nộp lại đầy đủ cái nội dung tính toán cho móng băng cho đến cái phần cốt thép. Mấy em có nghe rõ không?
Dạ vâng.
Đó là cái cơ
Dạ
hội
rõ.
cuối á, mà tới giờ đó mà không có nữa thì là năm sau gặp lại ha. Đó. Rồi, nếu không có gì nữa thì chúng ta kết thúc ở đây. Chào tất cả các em nha.
Dạ em chào thầy.
Em chào thầy.
Rồi,
Em chào thầy.
chào các em.
chào thầy.
Ăn
Chúc
Tết vui
năm mới
vẻ.
thầy.
Em tới đi vẽ à.
Rồi, cảm ơn em.